All right, we're live on YouTube. Just give me one more second. I'll just post it everywhere else on WhatsApp and other places where people are actually listening to us at the moment.
Cool.
All right, we're live on YouTube. Just give me one more second. I'll just post it everywhere else on WhatsApp and other places where we. All right. I think we're good to go. Thank you so much for being here, Jason. Hello, everyone. This is Minhaaj from SIDA. I'm the CEO of SIDA, which is an AI-enabled academic and industrial research company, as well as visiting professor of management sciences. We're back with Jason Mayes, who is a Google advocate for Tensorflow JS. And we're going to be talking a lot about one of the most curious projects that a lot of my students and colleagues have been asking about lately, and especially specifically with the interest in front end, which makes it more palatable or aesthetic, to put it in mild terms, as opposed to what some people might deem Python as the backend and more bland interface, to put it that way. Welcome, Jason. How are you?
I'm good, thank you. Thanks for having me on the show today. Great to see
you. Okay, Jason, if you could just briefly explain your role at Google, what do you do at the moment,
Yeah,
and how long have you been doing that? That'd be great.
sure. Yeah. So currently I'm the developer advocate for Tensorflow.js, which basically means if you're doing machine learning in the web browser or in JavaScript generally, because JavaScript can run anywhere, then there's a good chance you'll bump into me online when you're looking for support or trying to look at cool examples of what's being made before, or all of these kinds of things. Hopefully our paths will cross. Now, I've been at Google almost 10 years, but I've only been in this particular role for just over 1 year now. And before that, I was a creative engineer at Google, which basically means I was tasked with using emerging technologies to build world-first prototypes for our top 100 customers globally. So that's how I got into machine learning, in fact, because one of those emerging technologies was machine learning. And along with other things like AR, VR, projection mapping, and all these other things I got to research into. And I got to play with lots of cool technologies to make really cool prototypes. So I got very good at making prototypes, and then eventually managed to graduate to this developer advocate role that allows me to combine my love for web engineering, which is what I've been for most of my career over the past 15 years, with machine learning, and combine the two essentially. So super fun.
Okay. Now, we have talked before. I'm very happy that we actually got to know each other at EU Machine Learning Conference. I absolutely loved your session there, and we had a really great chat afterwards in the spatial chat room. And what I found really interesting about you is that you are not only the web engineer, because when we think of the web engineer, we have someone who's in teacher, then you're working with deep mathematical and programming issue, but you're equally good at explaining that, which is really kind of hard skill to find these days. And you have been teaching a lot in different areas. You are a Google advocate. That takes a lot of lawyer-like skills to actually advocate the cause that you deeply are passionate about. Most of my students happen to be PhD and postgraduate students, researchers, scientists, and most of my viewers are from academics. And sometimes when we introduce computer scientists and terminologies like deep learning and neural networks and machine learning algorithms, they find it very foreign to what that is, because that necessarily doesn't have to be very different, because it involves a lot of mathematics and statistics that they already know. But to explain to them what TensorFlow is and how does it actually relate with what they already know, how would you explain that?
So essentially, TensorFlow is kind of like Lego bricks, but for machine learning. So back when you were a kid, you may have played with Legos to make pretty much anything you could imagine in your mind. And instead of using physical pieces of plastic, we have mathematical building blocks that you can use to abstract yourself away from the mathematics, but make very powerful machine learning systems using concepts that have been tried and tested. So essentially, it's a bunch of Legos for geeks, which you can use to make anything you like, from computer vision to sound recognition to generative models and much, much more. So whatever you can dream up, you can potentially make it with TensorFlow and Tensorflow.js.
Okay. Now, to put that in perspective, let's think of a real life situation in which we would actually use TensorFlow. So what we do in academics is that, we have a problem. It could be social problem. It could be quantitative problem where we have a lot of data and then we play with that to find out the meaning of the data. So we have different tools for that. We visualize that data and find out the distributions, if they're skewed or there's kurtosis, a lot of other techniques that would help us understand the underlying problem. Now, machine learning is not very different in that regard. And when we use TensorFlow, we have different applications for that. So one of those where I was going through your Twitter feed and I found this teleportation project that you did. So very interesting project where we could actually see you in different places, and the computer program itself would actually make you seem like you're teleporting in real life. Just tell us about the brief idea and how did you actually conceive of that, and some of the
Yeah.
applications that you think of that.
So a lot of my ideas come from real world problems that I have. So in that case, it was because of COVID. Everyone was stuck at home, and it was very hard to physically meet people as travel was not allowed. And I'm from England originally myself. So that meant my friends and family are back home in England, and I'm currently based in San Francisco in America. So, regular Zoom calls, Google Meet calls, whatever it is that you're using, just didn't really cut it for me. You're stuck in this rectangle on a screen and it's very impersonal. So obviously I just joined the team at TensorFlow JS at the time, and they had launched a body segmentation model. And basically body segmentation is where you can take an image and identify the pixels in that image that belong to a human body and which pixels do not belong to a human body. Now, typically when someone uses this, they might have kind of other things they might want to do. Is maybe want to use augmented reality to kind of like label there's a body in the image or something like this. But I figured if I can take my segmentation and transmit it over the internet using WebRTC, which is web real-time communication, that's very easy to do in JavaScript. I can then make my own video chat client, but instead of sending a rectangular video, I can send a transparent video of just the segmentation, which also saves bandwidth. And I can then use WebXR for mixed reality to then render a plane of myself, so a rectangle in 3D space essentially, at a certain position in the real world, to then bring myself back to life again on the other side, as if I really were in that room. So that's basically where that idea came from, and kind of some of the technologies I used to implement it.
One of the most important things that I found, not from the conception perspective, but from the potential perspective that Tensorflow JS offers us. So, for example, if you were to do the same project in Python, so what you would probably have to do is, write a Jupyter notebook and then have the code ready, and then it would open another browser window, and then you would open that. But the unbelievable part with this Tensorflow JS capability is that everything that you want to do, you could do it in browser. If you could just shed this, you explain a little bit, how was that even possible, and what were people actually thinking when they actually created this project at Google?
Yeah, so I mean, one of the advantages of using TensorFlow JS over Python-based TensorFlow is that we can execute anywhere that JavaScript can run. And currently, that's many, many places. Not only can we run in the web browsers on the client side, we can also execute on the server side with Node.js. We can do desktop native applications via Electron, mobile native via React Native, and even Internet of Things with Raspberry Pi. So JavaScript is one of the only languages out there that can run in all of these environments without any additional plugins or add-ons and all that kind of stuff. So for that reason alone, JavaScript is pretty cool. Now, TensorFlow JS, the real breakthrough here was that some very smart people on my team figured out that you can do mathematics using computer graphics. And traditionally, when you're using Python-based TensorFlow, you have something called CUDA acceleration to leverage the graphics card on the low level to do the mathematics in parallel very, very fast. And that's great, very, very performant library. However, on the client side in the browser, there is no such thing as CUDA. You don't have driver level access to the graphics card necessarily. However, in JavaScript, there is something called WebGL, which allows you to do 3D graphics on the graphics cards. So you may have seen some fancy websites around doing some virtual reality or rendering amazing graphics in the browser for games and this kind of stuff. So all of this has been possible for a very long time. And what happened is people on our team figured out that you can actually use textures and shaders to represent the matrices that you need to use in machine learning, or the tensors essentially. And you can then use those to do the mathematics for you, to do things like matrix multiplications and all this kind of stuff. So by leveraging that, we're able to execute on the graphics card, which gave us a huge performance boost over maybe other libraries that existed at the time. And that's essentially what set us off being the go-to implementation for JavaScript. Now, fast forward to today, and we now have WebAssembly support as well, which allows us to execute very efficiently on the CPU. In fact, with the latest advancements of supporting SIMD in WebAssembly, which is some low-level instructions essentially that you can now leverage, we've now got comparable performance to WebGL. So the CPU is actually caught up with the WebGL performance, which is pretty awesome. Now, what's interesting is that there's a new standard coming out called WebGPU, which hopefully will give us more like CUDA-like performance on the GPU. Which then will bring us to parity. But this is an emerging web standard, and it'll take a few more years to come out and mature and be fully featured by all the web browsers out there. But these things are happening, so it's very exciting times for the JavaScript community right now. It's only going to get faster and better for machine learning, essentially.
Very interesting. I was just looking at the video from March 2018, where these founding members actually announced the TensorFlow JS support, and they mentioned about before actually I go ahead, if you could just briefly explain about this Playground TensorFlow JS project that they actually did, which was really famous around universities and schools, and they got a lot of queries about that. That would be good for audience to actually have some perspective.
There's a website. I think the website is like playground.tensorflow.org or something like this. If you just type in TensorFlow Playground onto Google, you'll find it. And essentially, this is kind of how TensorFlow JS started as well, because the original people on my team were tasked to making this kind of data visualization to visualize how a neural network actually functions. And this was aimed at Python developers, of course, to kind of give them this kind of web-based playground they could just go to in a single link and kind of experiment with different number of nodes and different number of connections and the different mathematical functions and hyperparameters that they can set. And they made this really nice visual interface. Now, of course, to actually make this work, it had to run in JavaScript to run in the web browser. So, they did some simple things at the time to kind of get something working in JavaScript in the browser. And that's when they realized, oh, actually, well, if we can actually do this in the browser to visualize things, we can actually do the machine learning as well. And, of course, that then turned into the Tensorflow JS project. We originally were called deeplearn.js. You might find some old material around deeplearn.js. That was basically Tensorflow JS before it was kind of cool, like we know it today. So, they started off with very low-level mathematical kind of layers to this deeplearn.js library. And honestly, I think I tried it back in the day, and it was far too hard for me to use. I'm not a low-level mathematical person, and I kind of stayed clear of it for many years until Tensorflow JS came out, and then they introduced like the high-level APIs, which is similar to Keras in Python, and that allowed people like me to then start using it in the web browser as well to kind of tinker around and make some basic neural networks to kind of do simple things like linear regressions or whatever it might be, but have a chance of actually making these things myself in the browser versus trying to deal with the actual mathematical operations themselves, trying to make neural nets from those, which is much, much harder. So, yeah.
One of the things that I was thinking about in terms of the future of Tensorflow JS, because when we talk about technologies or web technology in specific here, we think about how is that going to scale in future, because Google pretty much only works with clients which are billion-dollar clients, and at some point they would have to scale the models to a point where they would have huge data. Now, the authors of the library itself in that inauguration video explained one of the shortcomings that was true at least 2 years ago. I don't know what are the recent developments, but if you had to train the models, then you would like huge models, then you probably would have to do that in Python on premise computers or cloud or whatever you are having for faster processing, and then you can use the trained models in the browser where you could actually use it and put it out in the web application for people to actually use. Do you really think at some point you would get to the point where you could do that same in browser?
So we already can train models in browser, but you're limited by the device that you're using. So if you're using a mobile phone, then you're not going to have much like RAM and resources to keep all that stuff in memory, right? So, however, as I mentioned before, TensorFlow JS does support Node.js on the server side, and Node.js is our Python for the JavaScript world. So you have the same limitations as Python with Node.js. So basically, if you want to use gigabytes of data, you can use Node.js on the server side instead of Python, and you can train on that just as fast as Python, if not faster sometimes, because of the just-in-time compiler of JavaScript. So, yeah, I think use whatever you like on the back end for larger models, and then whatever comes out of those trainings, you can then potentially minify, make smaller, and then deploy to the front end if it is a good sized model. If the model you produce is gigabytes, there's no point sending that down to the client side, because no one's got time to download a gigabyte file to wait for the web page to load and then find it doesn't even fit in their RAM of their tiny mobile device, right? So this is something as web developers we're very used to dealing with, is not knowing what device you're going to execute on. But this might be something new to Python developers or machine learning developers, where they are expecting to have this high-end server with like the latest NVIDIA graphics cards, and it's always available. This is a different approach here, where you're executing on the client's device, which could be anything. It could be a Raspberry Pi. So, you got to account for that. And ideally, you know who your audience is and the types of devices they're using, so you can kind of account for those things. But typically, most of the browser models that we've produced, that we've open sourced, are like 3 to 5 megabytes in size. They're not massive. They're quite quick to download and to get set up, and then you can use them very quickly.
Okay. Do you know of any applications for Tensorflow JS, where it is actually connected to the real-time data, like humongous data, and that's coming from, like, let's say Amazon Web Apps, or IBM Cloud or Microsoft Azure, and then it's connected to the model itself, and then it processes that within the browser, and then displays the result, and it changes. I'm thinking of a stock market price app, which takes a huge data from the backend and process it right away, create models on the run, and then display that. Do you think that's some of the capabilities at the moment, or it would take some time before you'd optimize the performance within the browser?
So I mean, I've not seen anyone doing that right now, but I mean, it's in the realm of possibility if you had the machine learning knowledge if you know how to retrain the model and you're able to get the data coming in real time, you can certainly retrain a model live in the browser. I mean, if you look at teachablemachine.withgoogle.com, that allows you to recognize objects, detect sounds, or recognize poses, and you feed it data from your webcam, essentially, and then you let it train for a few seconds, and then you get a model that actually works straight away to then recognize those things. So yeah, this kind of stuff is possible. It's down to your model architecture and your knowledge of machine learning, if you can pull that off for like real-time stock data. And of course, your device as well. Again, if you're executing on a very slow device, maybe it'll be less than real time in terms of the retraining there. So it depends on the model. I think realistically, you're probably going to be waiting a couple of seconds or two for it to retrain. So you might be doing it in batches. You might get like 10 seconds of stock market data, retrain, and then have a new model every like 10 seconds or something. But that's going to be local on the client side. So you're still going to have to push that to the server side for other people to use, to download or something. So do you want to do that every 10 seconds? That's the bigger question. I don't know what's the advantage of doing that, but like maybe every day is definitely possible for sure. But then you can just do that with a cron job with Node.js on the back end. So there's some advantages to doing it on client side, I guess. But yeah, you have to weigh the pros and cons in your mind and decide if that's the right use case for you. Yeah.
It's very interesting because I was thinking about, in terms of there are three options. With stock market, you could either probably use, like you said, for the longer run, long-term investments, where you only need the data for historical performance of the company. And then we have the medium term, which is also fine. But if you're day trading and then you need it quite fast, then and you only are acceptable delays would be milliseconds, then probably that would be a problem if you're placing the stop orders on the high and the lows for the stock exchange. But certainly it seems very promising. So you're not familiar at the moment at all with any of the project that actually takes huge data and then on the run does that?
Not in Tensorflow JS, no. I mean, our community is only like 3 years old right now, so people are starting to think about like distributed machine learning in JavaScript and that kind of stuff. There's some community talk about this recently, but I've not seen one implementing that at present. But if anyone who's watching is interested, that could be a fun project to make. And if you make something, then please do let me know using our hashtag #MadeWithTFJS so I can find it and hopefully share it with people if you do make something cool.
Certainly. One other projects that I will especially wanted to talk to you about was the application of how people are using Tensorflow JS to really help and make a difference. So there's this one project that was shared on Twitter, which would actually build a machine learning prototype to help healthcare professionals verify if their face masks are safe and genuine. It's a very interesting project, and the video is very cool. Also, there's this guy who has this COVID-19 face mask, but what it does is the machine learning algorithm finds out. I'm not sure if you've already seen that, but
I think I've seen something maybe similar. It might be in the same project. There's been a few projects around this kind of theme. I think I know the one you're talking about. Yes.
Exactly. So it's it just changes different masks, and the algorithm gives the likelihood that this is the appropriate mask for you to wear. And I was just wondering if you could think on top of your head, or if you already know some of the projects that have actually been used in healthcare, on finance, or education, or in any industry, and that have had huge impact.
Yeah, I mean, there's a lot of prototypes coming out. Obviously, anything in the healthcare world is under much scrutiny to be having all the due diligence being done correctly. So, people make a lot of prototypes to kind of prove an idea out, but to get the FDA approvals and all this kind of stuff will take many, many years. So, but there's definitely ongoing research in these areas. I saw one guy from the Philippines doing stuff for radiology to kind of understand from X-ray images, bone fractures and this kind of stuff. And he was using TensorFlow JS so that doctors around the world could analyze these images like very quickly, but also preserving the privacy of the doctor, because the image is then never sent to a third-party server. It's analyzed live in the web browser without being sent to a server. So his image never leaves his machine, which is good for confidentiality reasons as well, should the patient not want that image to go around to other third parties. So this is a really cool use case. And once again, this is a prototype. I don't know where he is in getting approvals to use it at scale for that kind of thing. But of course, wherever medical is concerned, you need to do the proper due diligence to make sure the model you produced is accurate and is not biased in any way and all this kind of stuff. Because people's lives are on the line here. So you need to have a lot more scrutiny on those things. But I think these things with time will start to emerge in various forms, both with JS and regular TensorFlow too. I think things will start to come out for sure that do more things along these lines and empower humans to be better than they can be on their own, or to get through more cases in a given day and this kind of stuff. So this stuff is coming for sure.
Well, the sheer magnitude of what is possible through this is really mind-boggling for me. I was looking at one of your projects in which you simply disappeared from behind your computer using the Tensorflow JS. And I'm sure it was more of a fun thing, but I can think a lot of applications for that that could be useful. For example, if you're responsible for children, like really young children, and if they're approaching a stop where a line where they shouldn't be actually crossing, or on the road, and there is an alarm going off for the security personnel, and then one other application could be that these days in COVID-19 areas where times in which we have a lot of meetings from home, and not all homes are very quiet, and let's say children are children. So we could simply remove the background or the distractions from the background. So, so there's a lot of other applications that we could use for that also. I was just thinking, what were you actually thinking? And can you think of some ways in which people can take your model or an idea and expand that?
Yeah, I mean, that was a fun project. Definitely started out as a piece of fun. I just wanted to learn how to use the machine learning models when I first joined the team. I thought, what can I make that's kind of cool? So once again, this is using the body segmentation model that I spoke about earlier. And I tend to think about things slightly different to how most people would use a given model. So the person who invented the body segmentation model was probably like, okay, people are going to use this to find bodies and put stuff around them or label them or blur the background or something like this. But what I figured is that if I know where the body is, I know where it is not. And I can then remove the body from the scene by learning what the background probably is at a given time. So essentially, by taking that approach, I managed to then remove the body from the scene once it's moved around the scene enough. So basically, I'm calculating the background pixels as the body moves around to find out what the background actually is. So once the body's moved around a little bit, I then know a background pixel for all the pixels in the image. And then essentially, I'm updating the background pixels where there is no body. So if there's a TV on in the background, that will still be playing. But if they walk in front of a TV, you'll notice that the TV will pause. It's the last known good pixel to the background when there was no body there. But it still gives this really cool illusion of things updating. If anyone's looking right now on the Twitter post that I made for that, you can see when I got on the bed deforms even though I'm not physically present. So it looks like there's a ghost on my bed, which is kind of cool. But you can imagine, yes, for video conferencing, people at home, if you have a family sitting behind you, maybe you've got limited space, you can choose what humans to keep in your video stream when we're on Zoom and Hangouts and things like this. And that can be very powerful for people who have limited space and that kind of stuff. And maybe even in like the movie industries and things where you want to try and get a scene of New York or something with no people in it, like an empty city, which is very hard to do without spending a lot of money. to actually shut down the street and have no one on the street. Maybe using something like this, I think it would need to be modified slightly, but something along these lines you could then use to automatically remove the people from the scenes to give you this kind of like apocalyptic kind of scene of a city of the future or something like this. So which could be good for like movie industries and stuff like that. So there's many of applications, and I'm sure there's many others that I've not thought of that could be very creative as well. So I encourage people to have a play. The code is online, so yeah.
Yeah, I was just wondering, I mean, is it the results are, what is the accuracy in comparison to the results that you could simply achieve from the green background? So in Zoom, we have something called like ChromaKey, where you could simply have the green background and you could
Right.
remove.
Yeah.
And I
So
was just wondering,
obviously,
would that be more realistic with Tensor.js or?
yes. Yeah. A green background would be more realistic in its current form. So in the name of efficiency, I use kind of a rectangular mask. However, if I were to go on the pixel level, then it could technically be as good as a green screen, but would currently it would be like maybe like 5 frames per second instead of the 30 or 60 that I've got right now with my current implementation. So I made some hacks to make it faster. But with time, things will get faster, models will get more efficient and smaller. So these speeds can then be got for pixel level segmentation data too. But yeah, I think it's definitely it's possible to do it as good as a green screen for sure. But it's currently possible in today to do that if you wanted to. But the model that I used, the body pix model, I don't think it was trained on webcam data. It was trained on maybe like really nice footage from HD cameras and all that kind of stuff. So it expects a certain quality of image, and it doesn't perform so well in low light conditions to segment the body. Like it works kind of well, but there's like a slight halo, or like it doesn't get the foot sometimes or something like this. So I think to do this perfectly, you need to retrain a model like that with custom training data specifically for webcam environments. And it will then be able to do that much faster and more efficiently on the accuracy as well. So.
Okay, because I remember watching a project that's also made in Tensorflow JS. So there's this one guy, who has got his hand out, and then they have different data points on his hands, and when he moves his fingers like this, the data points move along with that. It's a very good estimation of where your body is. And I was just wondering, there could be a lot of applications similar to that in the field of prosthetics, which could be very useful. The doctors to actually see after an accident to see if your hands are working fine, and there's some deformities and things like this.
Yeah, we've got people looking into kind of healthcare applications where I think one application was trying to detect like the early signs of like was it Parkinson's or something like this? Like if you start to like walk in a certain way, or you're like less stable, it can kind of detect these movements and kind of analyze that in some way. And then there's another one that was what was it now? I've forgotten. There are other applications along those lines, like yoga estimators, like so you can do your yoga workouts, that kind of stuff. So you check the pose of the human body, make sure they're in the correct pose for a certain number of seconds. We've also seen people do kind of fitness instructors. So when you do the repetitions for the gym counts and things, it can do that automatically, all powered by Tensorflow JS in the browser. So you just go to a website, start your workout routine, and it will count the reps for you and tell you when you're done and that kind of stuff. So these kinds of things are being explored by the community, and some cool results for many of these things coming out.
It's very interesting, what are the possibilities with the project, with so many projects. And, once again, I would really request you to not only use the hashtags on Twitter to keep count of these projects, and actually make a page through community or, like-minded people who would actually have all the details of a project, how it is conceptualized, and the GitHub for that. And if someone wants to improve that, I think that would be a huge service, especially given the fact that how potent the idea itself is and how it can be scalable. But let's go to another topic, which is really interesting, and we have talked about that earlier also.
Yeah.
Making a product itself is only 5% of the job. We know that through data, through I'm still studying so many use cases of different companies. A very valuable skill is to be able to actually market that, to find the relevant people who be able to pay for that and then sell it. And you seem to be actually excelling at both of these parts. I mean, you do a lot of advocacy on that, and you have done that in your previous jobs also. I mean, if I look at your resume, a very small part of it is the development itself. A lot of it is very creative ways of displaying and dishing it out to people who are who would be more interested in that. Now, especially working at Google, which is of course a business in the end, and your return on investment is probably the bottom line for that. How important do you think it is to actually make a product and not only think in terms of what is possible, but also what actually sells and what problem does it solve for people?
Yeah, I think I've always defined myself as a hybrid engineer. So, I mean, I've been an engineer all of my career for over 15 plus years. I've always been coding, but I've always tried to produce things that I know could be very good business propositions as well. It's not just research for the sake of research. It's actually coming up with ideas that can be sold to clients or can be used to make the world a better place or something like this. It's got some end goal in mind. It's not just this thing that will never be used. And I think that's very important to always have in mind, like an end goal for the thing that you're producing. It's nice sometimes just to have some playful time coding things and it doesn't go anywhere. That's fine. We've all done that at some point. But I think for the work that you're producing, at least, it's very good to try and have an end goal in mind of why you're producing that and have something, some kind of endpoint which you want to get to. So maybe for things like I made a clothing size estimator recently in Tensorflow JS that allows me to, in under 15 seconds, understand my various body measurements to automatically at checkout on a web page select for me small, medium, or large for say a t-shirt or something like this. And once again, this came from a problem I had in real life where I really don't enjoy buying clothes. I do it like once a year, as you can probably tell from my current attire. And basically, I never know what my size is and all this kind of stuff. So essentially, I thought, well, I can solve this with machine learning, right? And I figured, okay, if I can measure parts of my body, I can then calculate what size I need to have at checkout, which then, of course, saves me the hassle of having to return things when they don't fit. And of course, it saves the company money because they don't have to pay for the shipping costs to and fro. They can make a greater profit too. So it's like win-win for everybody. So I encourage people to think of ideas that can solve problems in their lives or can be useful to the community at large. I've worked with MPOs in India that do things like identifying pests in fields of the crops to know when to spray the fertilizers and this kind of stuff. So, there's many good use cases you can be doing for that thing you might have had in mind if you just apply it in the right way. And I encourage people to be more creative on that side. I see, some of the most creative people I've ever met are actually engineers, but they forget to actually go down that path. They sometimes get stuck on the coding and the research and get hung up on those things and forget to kind of explore other opportunities that might be around that area to innovate and make new things that have never been made before, rather than re-implementing some research you've just seen. Why not go one step further and combine it with a different thing from a different industry to make something that's never been made before? And that is what leads to great startups, great business ideas, and profitability longer term as well.
I think you brought up a very interesting point here. I mean, I wouldn't have actually thought about this, but I think it's a very good point that, you mentioned that engineers, they generally are very good at what they're doing. They're very creative with things.
Yeah.
But what I've noticed in our own experience at SIDA, we employ a lot of machine learning specialists, data scientists, programmers, frontline coders, and other people. And one of the things that I noticed that we as a company are very focused on mental health, understanding yourself, personality, talking about that, what makes you more comfortable working at the company, what can we do for you, and what are the things that you would require. But a lot of companies don't. Sorry. And when engineers they think of something and they know how to actually build that, it's very rare that they actually have the right words to explain that. And that's something, this is why, we have a lot of project managers and technical
Right.
managers who would simply bridge the gap. So there's a whole industry that only exists because, they want to translate what engineers actually say, and then explain it to people who are in marketing, who are in sales, so that they would break it down for in a language that people will simply understand. So
Yes.
I'm pretty sure that you'll work with a lot of engineers. You're an engineer yourself. What are some of the advices and things that you have noticed that would really help engineers explain themselves at work?
Yeah, I guess, you have to remember that the other 80% of the workforce in a company is probably non-engineering, right? You got the sales, you got marketing, you got other people in the company that exist too. And I think the biggest problem I see, and myself included, when I was a younger engineer in my career, like you forget the knowledge that you've gained, and you forget that everyone else is not born with this knowledge. So you might just talk about something that is kind of casual for you, like, oh yes, I'm just going to talk about, I know, um, I don't know, multi-layer perceptrons, and you just think that's such a basic form of machine learning. Everyone must know what that is. No, they don't. And you didn't either. At some point in your life, you had to learn what a multi-layer perceptron was and how it worked. And I'm sure you probably had a few moments, many hours of like, what is going on here? Like, why am I not getting this? And some people don't even have any interest in learning what that is either. They're not even in that industry. So you have to be mindful of that and phrase it in a way that they can understand. And this comes with practice. Honestly, there's no like kind of just do this and it will always work. But like as you start presenting to higher up people like directors, C-level, this kind of stuff, they want to be told things concisely. They want to know what the benefits are and the cost to the business, essentially. So if you're trying to pitch a new idea that you want to work on, you can't just nerd out on the tech stuff. You need to kind of pitch it as a business proposition to the stakeholders who can give you the resources to then go and do that. And this comes with practice. Writing a 10-page essay is not actually good here because they simply won't read it. So even though you might think that, okay, I'm going to put all the details into a nice big design doc, and it's got everything they could ever need, every question is answered, that's great, but no one's going to read it. So you want an executive summary of sorts. But imagine you're stuck in an elevator with someone, you've got 20 seconds, and you've just met like the CEO of your company, and they're in the elevator with you, and you've got this new idea that you want to actually start working on, but you don't have the resources to do so. How would you pitch that in the elevator ride to that CEO to get the money by the end of the elevator ride to get the headcount or whatever it is you need to do this project? And ask yourself that question, and you'll find it's actually a really complex art to be simple. Simplicity is a complex art. My friend said that to me many, many years ago. It's a phrase that stuck with me, and it's very true. As an engineer, I can be very pedantic. I can be very obfuscated very easily. I can talk a lot of big words and confuse a lot of people. That's not hard to do at all. But explaining something simply to someone is tremendously hard. And you only can do that if you truly know that thing inside and out from the fundamentals. And I think as you progress in your career, as you get more knowledgeable, you tend to take more mentorship roles. And it's at that time you realize you can explain things simply to kind of spread that knowledge. So I'd encourage people to keep doing that kind of stuff and to practice those softer skills that you might not typically do day to day in your engineering roles. But it will actually be very important to you later in life as you move around companies or maybe start your own at some point.
It reminds me of a quote from Einstein, I guess. He said, if you cannot simply explain the idea that you have, then you probably don't understand it yourself.
Yeah.
Really. And that kind of rings bell in a way that, it's easy to confuse and impress people who don't know better, but then you cannot actually build a rapport with them if you
Right.
are impressing them. It's more of like of intimidation. And a lot of our clients, when they approach us, they think of us as like these sophisticated companies who do very complex things, but when they actually when we actually tell them how easy that is for them to understand, they simply get the idea. But why do
Right.
you think that people actually do that? Do you think that has something to do with the education at universities? So when engineers actually go there, there are no like public speaking lessons or
No,
presentations or
I,
social cues?
I think it's for good reason. There's a reason we have the words that we use and we say the words in a certain way. And it's for preciseness. When you're talking to another engineer, you need to get across like, the exact implementation you want built to a certain specification. And if I use more generic words, higher level words, it won't get across the nuances. So there is a reason why we have the language we have. And there's nothing wrong with that when you're talking to other engineers. but but bear in mind, other engineers at the same level as you. So, when you're talking to maybe someone who's new, you can't assume they know all that knowledge. And it's wrong to do so, in my personal opinion. I think you should always assume that people might need things broken down, because people, and this is a very engineering trait as well, like myself included. It's very hard for an engineer to admit that they don't know something, because it's kind of admitting defeat or something. And I think I was
Just
one of
like
the
all
first
of us.
people within Google to say like, hey, you know what? This machine learning stuff, it's too hard. I don't get it. And that's when I started making my machine learning 101 deck to try and unravel this onion that was machine learning that I was finding particularly hard. I've got a master's in computer science, and I couldn't figure out how to use the darn thing. So I spent many hours and many months trying to just talk to intelligent people and trying to decipher what they were saying in a way that I could digest. And essentially, I made this deck that's like 101 slides long that has all of those aha moments that I had in one deck. So hopefully it makes it less of a problem for other people getting started with machine learning to get that high level knowledge very quickly to then unravel the onion, so to speak. So yeah.
At one of those points, I remember it was kind of a funny story where we actually took a person from the sales and the data science and put them together in the room. And I was telling me, you're not getting out unless you understand each other. And that unfortunately turned out very well, but that's not the norm. I can tell you that.
Right.
Now,
Yeah.
let's talk about engineers and it's not between engineers and sales that there's always a rivalry. That's also between engineers themselves also. So
Yeah.
JavaScript has been a bit of a joke for quite some time now
Yeah.
by the backend stack developers now, because they don't think that it is a real thing. It's more of a toy language.
Hmm.
Not only does the statistics suggest otherwise, but mere dependence of backend on front end speaks for itself. I think we have like 65% of upcoming jobs are in JavaScript, I believe.
Yeah.
How do you see it, and where do you think it's justified, and where do you think
Yeah.
it's more of a joke?
So I think this stems from the very early days of JavaScript, where the language itself was created very quickly, and it was for a certain purpose, and it did that purpose very well. It was for the internet, the very beginnings of the internet, right, where we needed to transmit simple documents to each other and do certain things, and it was good enough for those kinds of things. But of course, back in those days, and I'm talking like 1970s or whenever it was that it actually came out, it didn't do much else other than these simple kind of things. And it was a programming language, but it wasn't rich in other ways and having support for other things. And people often got freaked out that it has, it's not strictly typed and that kind of stuff. Now, fast forward to today, and it's actually matured incredibly since those early days, and it's a very, very powerful language. I mean, it even is used on the SpaceX rockets that go up now to power the astronauts' console in there. It's JavaScript. JavaScript made it into space. So it's not a toy language, and it's being used for real world things. And I think, you can be a good engineer in JavaScript, you can be a good engineer in Python and any other language. It doesn't really matter. The main thing is that you make stuff that matters. And what language you choose to use is kind of besides the point, in my opinion. Like, it's like talking about is Apple versus PC and which one's better. Like, it's what you use at the end of the day. I'm a PC fan, but if someone else uses Apple, whatever, as long as they can get their work done and do the stuff that they need to do, who cares? So the point is here that I think, yes, there is like some inside jokiness about JavaScript sometimes. It's seen as a toy language, but I would argue, I challenge you, in fact, to make things faster than me for the prototypes that I've created. My invisibility cloak I created in less than a day. The teleportation, just a couple of days. My clothing size estimator, just 2 days. I challenge you to do that in something like Java or Python, and have the reach and scale that I have as well, which anyone in the world can use, and try and do that in 2 days or 1 day or whatever it is that I did. And it will be harder to do in other languages. JavaScript is very powerful for computer graphics. It's got very rich libraries that run across devices. And web developers from day one have been always thinking about running on the nth device. Like, we can run on smartwatches, we can run on smartphones, tablets, laptops, desktops, 40-inch screens, conference kiosks that are 60 inches plus. And we have to design our applications for all of those environments and to gracefully degrade or progressively enhance and that kind of stuff. And I think having that kind of mentality is actually very good, because it then allows you to think about these edge cases that might be overlooked from a traditional backend engineer who's just has like one environment to deal with. So I think actually it makes you find these kind of other possibilities that typically aren't possible as well. So have a play, try it out, and you might be surprised how far it's come. And yes, it's not strictly typed, but there's things like TypeScript if you really want to have that. That being said, with great power comes great responsibility. So the fact it's not strictly typed is actually quite useful sometimes. And you can even send around like functions as first-class citizens and all this kind of stuff. So it's a very powerful language, but you can have a lot of potential to mess things up with that great power. So as with any language, you've got to be responsible and make sure you know the nuances of that language. And every language has its quirks. And like, JavaScript included, there's certain quirks there that you need to know about. That do exist, but once you know them and you know them well and why they are the way that they are, you can actually code very confidently and produce some really great applications that run anywhere.
I was just talking to some friends at our studio, and ours is probably more of an academic thing. But what I'm seeing lately is that there's always a will to create interfaces of other languages within the language. For example, our studio is now started a translation framework for Python within R, and I think JavaScript is one extension of that also, that is coming under the fold. So I was just wondering, would we actually get to the point at some point where we could simply use our tool and that would simply translate and talk to each other at some point?
I think definitely there's more intermediate formats that come out, allow you to kind of cross boundaries with languages. There's also transpiling going on these days and that kind of stuff. So we're already starting to see that kind of stuff come out for sure. So yeah, I think this kind of stuff does exist. And in the case of machine learning, maybe there's going to be some formats that you can transform into to then go in some common language, kind of like we have like JSON these days to kind of communicate across programs and environments for data exchange. Maybe something like this will exist for other kinds of problems like machine learning and so on and so forth. And already there's various committees and people looking into these kinds of like standards for machine learning, so that you can like use something from PyTorch in TensorFlow or this kind of stuff. So I think these kinds of things like will eventually emerge just out of necessity, so that people can use things in different environments. And I think we'll see more of that as the communities mature.
I mean, one of the more impressive developments actually is the applications of GPT-3 that we have seen recently, and the automation of the language itself. For example, JavaScript automation through a company called Bubble. I'm not sure if you have heard about this. I shared that on my LinkedIn a couple of days ago, and you could simply do everything from the behavior of the windows and pop-ups and marquees and everything by drag and drop within the Bubble framework.
I see.
And I was just wondering if that's something which would make languages obsolete at some point, because the capabilities of GPT-3 are astounding, because you simply have to write text instruction and it would do it for you.
Right. Yeah. I believe, and this once again, just to reemphasize that this is my personal opinion, I believe that the low-level languages of tomorrow will be our high-level languages of today. So what I mean by that is that I think there'll be a shift in the same way that we went in the 19 whatevers from assembly code to C. And trust me, a lot of people back then were like, well, why do we need C? We can just code in assembly. And of course, anyone today would be like, well, that's just a big waste of time. So like, our compilers are now efficient enough that you don't need to actually hack in assembly to get the best performance. We can write in these high level languages. And I think the next shift, which, I've had some backlash from engineers on this one, I do believe visual programming is what will be the long-term winner and will get the most number of people in the world making things. And that's why it will be the long-term winner, because it's more than just 1% of people able to then program. However, the existing languages of today, like, Python, Java, JavaScript, all these things, these will be considered low level in, let's say, a few decades time, maybe. And that's what people will use to implement the new widgets and things that these high level visual editors would then use. So I see things going in that direction already. So if any of you are familiar with the Unreal Engine, which is made for computer games, they have typically have a C++ API, but they also have a visual editor that allows you to make the games too. And it's basically writing the C++ behind the scenes, but it's very customizable, and you can make really powerful games using it. And I tried it once. I was really surprised. Like, there's almost no difference in the end, like efficiency, the output of the game. Like, you can make this beautiful game in both ways, and there's like pretty much no difference between the two. I was like, that's amazing. And I think we're going to see more stuff like the Unreal Engine coming out, essentially, how they work, where they got this C++ API for people who want to get low level and do things, but they got this visual editor as well that allows you to kind of connect these high level concepts together to explore ideas, or to make things quickly, or to do certain things that are common very quickly, at least. And I think we're going to see the same kind of stuff come out for other fields as well, like machine learning and this kind of stuff in the future, maybe. So I'm excited to see where it goes. But yes, I think programmers are still going to be required. So I don't think that's going to go away. But I think it will just enable more people to have a chance to make things. So previously, maybe someone like my parents don't know how to program, but maybe they have an idea they want to create. And if they have some visual editor, they can actually do like a if this, then that kind of situation for various high level concepts. And they can make very powerful systems using that kind of tool. And get something that works and then just automatically deploys and is served on the web server somewhere just automatically. They don't need to worry about the back end and the server side scaling and security and stuff like this. It just is kind of handled for them. But it allows them to have the ability to create things. And that's why I think that has the potential to grow the most, because, maybe 2% of the population actually program right now. It's not a lot as a job, at least as a role, as a job professionally, it's a very low number of people. So other people need to know how to do this skill at some point, and I think that kind of editor will allow them to, and that's why it will get popular with time. As industries mature.
I totally agree. Now, Jason, outside Google, you're also as a person. So let's talk more about Jason, not as a web engineer or a Google advocate for TensorFlow JS, but who you are at the moment. And many of my students, when I do these podcasts with brilliant researchers and professors and influencers around the world, I want to ask these questions both for the good of my students, for me, and for my colleagues and viewers. To be able to give them a window into the kind of mindset that is required to be able to achieve such feats that you have done. And one of these questions that repeatedly occurs in connection with Google is that how hard is that actually to get into Google? I mean, what is the anatomy of engineer who's working at Google? I mean, what is the background that he needs to have? I mean, what is it? What does the childhood look like? How does he approach things?
So there's no fixed criteria. Like, technically Google does not require you to have a degree to work at Google. So, if you kind of decipher this, like, well, what's left then? So basically it comes down to who you are, your skills, and proving that you know those skills, So yeah, essentially you want to have like a really kick-ass portfolio and be known for a thing, especially if you don't have a degree. I bet that's going to count a lot for you in terms of hiring, right? So I think you need to be able to sell yourself well, which comes back to our previous conversation earlier, like learning how to sell yourself well and knowing what you know and also what you don't know. So you know what you need to improve on, or maybe delegate to some other team or other person in the future as well. This is also important. So, okay, so repeat the question again. I've gone off on a tangent there. So, what was the essence of the question?
Yeah, I mean, one part of that would be how to get to Google, but then more important is what is the mindset of a person who would end up at Google?
Yeah.
How would you approach things in school? I mean, what subject should be
I see. Yeah. Again, so this is not like the recipe for how to get to Google. There is no set recipe. It depends on the role. It depends on many things, right? But my personal background, I started off in computer science. But as I said, that's not a requirement to become an engineer at Google. However, I then moved into startups. I worked for a semiconductor startup for several years as their lead web engineer. I then started my own company for about a year. It was basically a web agency of sorts. So I was director of that. And then Google reached out to me and were like, hey, do you want to work as a web engineer for us over in the London office? And I decided to put my company on hold and do this for a few years. And here I still am 10 years later, now over in California. So I guess, at some point I might decide to go back to a startup lifestyle. But right now I'm enjoying the ride at Google. But, I think the one thing that stuck with me prior to Google is that I was very proactive. I didn't ask to do something or kind of like, oh, I'm going to wait till someone does something to then do this other thing. I'll just make stuff and do things that people got excited about, and that's what eventually got me known and found by Google in the first place. So I believe the recruiter found me because they searched web technical consultant on Google, and I was like in the top 10 results there, and they reached out to me because of that on my LinkedIn profile. So, how did I get that page rank? Well, because I was writing articles on blogs, I was writing in magazines, I was helping charities out. I was working for free sometimes, just doing stuff for fun, just to help a charity out. And when people ask them who made your website, it was like, oh, this guy Jason did it. And then so you get this kind of you get associated with these certain things, and that then allows you to be found for other things later on, essentially. So I think generally being a proactive person and doing good things in the world actually gives you kind of a good return longer term, because even if you're not even paid for that thing, it's the exposure and the association of you being knowledgeable in that area that's more important here longer term. Short term financial gain is great, but long term it's the reputation that will keep you in business long term. So keep working on the reputation, I think is my top advice there, and be known as the expert in that thing that you're very passionate about. And ideally, if you can, combine two industries. So if you're a computer scientist, great, but what else are you passionate about? Maybe you like music. So then make something that does computer science and music and be known as the person who can do those two things. And I guarantee very few people these days bother to learn more than just computer science. So if you can show that you can connect industries together like that, all those music startups or whatever it is, high-tech startups out there, Spotify's of the world, they'll come to you rather than the other computer scientists, because you've already proven you've got the passion, you've got the experience, and you've got the knowledge to kind of cover both verticals. And that's very hard to find.
Okay. Now, you have been a business owner yourself, which is a huge plus, especially in the role that you are at the moment with Google Advocate. You understand where people are coming from when they're looking to hire someone, and then you also know the people who work on the core product, like engineers. So, what do they expect from people who give them requirements? So, you come from both worlds. You have seen everything. Tell us a little bit about how is that once you're hired at Google, what is that to work? How is that to work in Google? I mean, what kind of a working environment it is? I mean, you certainly moved from UK to San Francisco also, I guess. I don't know, how long have you been in San Francisco now?
Almost 5 years or so, I think. Yeah, coming
Yeah.
up to
So
five
I'm
years.
pretty sure that the culture across the pond would be very different, and then there's a huge new world with brilliant people, more smart people around the world coming to these valley to work in this prestigious institution. What
Yeah.
is that to work? I mean, how does it look like?
Um, Honestly, like when I first joined it was basically an honor to be working with such amazing people, because like the person who would interview you is like literally the guy who wrote that book that you read in computer science. Or or you'd be walking down the corridor and you meet someone like Vint Cerf, who literally invented the internet. And you can just stop and have a conversation with these people. It's really amazing. And you do there's this terminology called imposter syndrome. It's like, why am I here? Like all these great people are around, and like, why am I here? I've not invented the internet. So I think that's something that's common across Google, is that they get this imposter syndrome almost, which is good because it keeps you humble, and like you've always got something to learn and you should never stop learning. And I think the thing that I love the most about my role at Google is that it allows me to stay curious and to dive into those curiosities. So when I was at a startup, it was much harder to do because there's less resource to maybe do a training, or take some time. 20% time is very famous at Google, to take one day a week to do your own thing, which at a startup is very hard to do because every head counts, because there's only 10 people and you need them to be doing the things that are productive to the business. So that was a big shift from my startup lifestyle when I moved to Google, was to be able to do these other explorations and get the resources to explore those things. So that's one of the advantages of working for a larger company. But at the same time, there's other benefits to working for a startup too, of course. Like I do miss wearing like all of the different hats I had to in startups. Like once you get to the larger companies, you're picked to do a certain thing very well. So it's more niche kind of slotting for what you'll be working on. Whereas in the startup, like one day I could be doing web design and programming, and the next day I might be doing 3D modeling in Maya to like try and replicate their products for them to get the perfect shot. So like they complete variety of skills required there. Whereas now that I've been at Google for 10 years, I've very much refined my skills in a certain area. And for me, that's web engineering using JavaScript, and starting to now refine my machine learning skills too. I'm still very much not an expert in that, but I'm hoping that as I learn, the world can learn with me, and we can all go through this learning process together. So jumped in the deep end on the machine learning side here.
Superb. Now, I was reading one of the articles at Business Insider recently, and it stated that Google career certificates are now changing the higher education by offering an alternative career path than traditional universities. Now, we know that companies like Facebook and Microsoft has already abolished the college degree requirements for recruitment. Um, how do you see this development where you wouldn't actually need a certain degree before you even apply for the things? I mean, we have talked before about this also, and you declined a spot at at Cambridge to go to Bristol University, which suggests that the big names might not be as big
Yeah.
as we think of them, and the quality of education and your interest matters more than what would be fashionable for everyone else. How do you
Yeah.
see this development?
Yeah. I think you got to follow your heart really, and what's right for you, because the reason I've declined some offers like that in the past is because the course at Bristol was very unique at the time, and it just felt like it was the future in terms of what they're producing, in terms of their research and stuff. They were very strong in like cryptography, 3D computer graphics, and all these kinds of areas, and those are more aligned with like my interest at the time. So I was like, okay, Bristol is clearly the winner here, versus what was being offered at other universities at the time, which is more theoretical and that kind of stuff, which is great. But I want to use this in a real job afterwards, not just the theory. I want to actually do something with this. And Bristol was offering the skills to actually put things into action and to learn how to like sell those things through. In fact, for my final year thesis, we weren't allowed to just come up with novel research. We had to have novel research with a business plan to turn into a real startup. And I think Bristol University in England is one of the highest output of startups, at least from the computer science department. For that reason, they do this, and it makes you think in an entirely different way. And I can't thank them enough for forcing me to do that, even though I didn't apply. My degree is not business and computer science; it's pure computer science. But they still forced that requirement upon us to think in that way, and that was very valuable. And it's something I've taken with me to this day, and I apply it to all the work that I do. So yeah, in terms of education, yes, it can be advantageous on paper to maybe sometimes have a degree. It might give you a little head start in some ways, but the main thing is to prove that you can do the same quality of work as someone with a computer science degree. And if you can do that, it doesn't matter. And as I mentioned before, Google does not require you to have a degree to work for us as an engineer. As long as you prove that you're knowledgeable in that thing that you're applying for, and you code to the same standards and all that kind of stuff that is important as an engineer, then it's all fair game. And it comes down to the rest of the interview, like your personality and your other skills that we mentioned before as well. So yeah.
I take a lot of interviews, and a lot of those applicants are very embarrassed of the fact that they don't come from elite universities. And I simply quote them a recent article from Harvard Business Review, which actually does a fantastic research about the performance gap between Ivy League students and the normal league universities. And it wasn't much at all. So it means that, just because you come from a good university, it doesn't actually generate wealth for employers as much as we think it is.
No. In fact, I almost, and once again, this is my personal opinion, but I question, especially in the more expensive countries like America, the value, the reward, the return on investment, if you just talk business terms here, the return on investment of, if you're spending $100,000 a year in debt, what are you really getting from that makes it worth that much? I mean, in England, we thankfully don't spend quite as much, but even so, the prices are going up all the time. And, I definitely wouldn't change having done a degree. I still value those days a lot in my life. I learned things very nicely from very, very experienced people, professors that I respect a lot. And I still would have done that degree again if you asked me to redo my life. But that being said, if you don't have the finances to do such things, should you be worried about that? And I think the answer is no. And I think that as long as you are passionate and you put the work and time in to really become an expert in that thing, you can be just as successful, if not more so. In fact, most of the dropouts from the American ones go on to form Facebooks of the world, right? And Zuckerberg was a dropout from university, I believe. So, he didn't even finish his degree. So, there's lots of famous people who didn't finish their degrees and went on to start amazing companies. And I wouldn't get hung up on that piece of paper. The more important thing, in fact, myself, I was offered to do a PhD after my master's, and I declined because I was like, I can spend another few years doing this, and that's great, but I can still get the same knowledge by just doing this in my spare time for the fun and love of it, and get paid at the same time. So I'm like, for me, it was a no-brainer. I was like, I've got enough knowledge now to go out into the world and live on my own 2 feet. I can survive with the knowledge I've got from my computer science degree and good practices, but I don't need to do a PhD in that case. For my circumstances, let's be very clear. Everyone's got different circumstances. Maybe you want to go on to be a professor or something, and it requires you to have a PhD. That's a different set of criteria. But for my circumstances, what I wanted to do with my life, that was good enough. And I didn't need to do further studying, because for me, I'm going to be doing it anyway in my own time. And for me, it's about the understanding of something and knowing it well enough at its fundamentals. That's what excites me to learn something new. And I can do that with or without a university. I still do that to this day. If I'm not learning something new, I feel very unsatisfied in my life. So You should always be learning new things, even when you're not at university. And I think that goes back to my point on being proactive and all this kind of stuff, and keeping yourself busy, trying out new ideas and exploring things all the time. And in the world of computer science, that's very important because our industry moves so fast as well. If you're not doing that, you're going to be unemployable very quickly as well, because things will have changed within 5 years, and the things you know today won't be relevant tomorrow. So yeah, I think it's in our nature to have to do that as computer scientists and engineers.
Fantastic answer. I think, people should do things because they want to do it, not because, it makes
Yes.
them look cool or for others. Finally, tapering off this interview, let's talk a little bit about how it is your life outside work. I mean, I think it's a huge responsibility. Like you said, there's a lot of power when it comes to you. There's also responsibility, but what do you do to actually plug off? How do you actually relax? Do you work out? What do you
So
do?
before the COVID situation, I love to travel places and experience new people, new cultures, that kind of stuff. My mission is to go to every continent on the world at some point. And then other than that, before I got into technology, I wanted to be a pilot in the Royal Air Force in England. So I try and keep up my hobbies related to flying whenever I can. But obviously, it's a little bit pricey, so I don't do it all the time. I just do it now and then. I don't have a license or anything, but it's fun to take an odd flying lesson or try different forms of flight out. And yeah, my dream, my personal dream, is to go into space one day and tick off finally all forms of flying. I think I've done everything apart from gliding and going into space. So that's the final two things I need to tick off my list. And then I've done pretty much most forms of powered flight, at least. I've not done parachuting like skydiving, but I've done things like paragliding and that kind of stuff. So anything that involves some kind of contraption, I've pretty much tried out at some point, I think now. So it's a fun thing to do.
What's next?
Yeah.
Make you a very good candidate for Tesla, I believe. Okay. Thank you so much, Jason. It's been a pleasure talking to you. And I think this is a very good point since you love traveling, to invite you to Pakistan also. We could have this face-to-face interview, and a lot of people would be dying to listen to you and talk to you more.
Awesome.
Thank you so much again. And hopefully we'll continue our partnerships and collaboration in the future also.
Sounds good. Yeah, thank you. And yeah, hope to see you at some point in person once travel opens up.